Welcome to the lair of the Batty Boffin.
Hi there Batty fans, welcome to another one of the electricity series of videos from the Batty Boffin. Now this video is a little bit different from many of the others because this one is all about static electricity. In other videos we've talked about electricity that goes around currents, like the electricity that's in your house or the stuff that comes off batteries, but here is static electricity, which was actually discovered decades, centuries before current electricity. Everybody knows about static electricity, lightning is static electricity, and I'm sure you've had the experience of either taking something off over your head and finding your hair goes or perhaps sheets or blankets that make a noise like that, or perhaps touching a car and getting a shock from it, or even another person. All of those are static electricity, and here is how it works. Everything around us is made from atoms, with other videos that talk about those later on. And one of the parts of atoms, the outer bit, is called an electron. And an electron holds an electrical charge, and we draw it like that, a little minus on it. Okay, so everything's got electrons on it. This cloth has got electrons on it. This balloon has got electrons on it. And we can make those electrons move. If I take my balloon and rub it with the cloth, I'm actually scraping some of the electrons off this cloth and they're landing on the balloon. Sometimes the electrons will go from cloth to balloon, sometimes they'll go the other way, depending on quite what the things are made from. Certain things, amber for example, is well known for charging it, which is one of the reasons it's got the name amber. But I happen to know that when I rub this balloon with the cloth, I'm taking electrons off the cloth and putting them on the balloon. You can do the same thing like rubbing against a woolly jumper and all that kind of thing. So when I'm doing this, here's my picture. I'm making some of the electrons jump from here and stick onto the balloon, which means the balloon's got more electrons than it would normally have. So that means it ends up with a negative charge on it, a whole load of extra electrons. Now, of course, if there's extra electrons here, then there aren't enough electrons here as there would normally be. And we show that by a positive charge. The positive charge just means there aren't as many electrons as there should be. So if you haven't got the negatives, then what's left is a positive, if you see what I mean. So we end up with the balloon having a negative charge and the cloth having a positive charge, in the result that they should attract one another. And hopefully that balloon should be kind of slightly attracted to the cloth there. So we've got our negative charges and our positive charges. But the bit where this really comes in interesting is, what if we put this balloon up against something else? Now, as well as having a negative charge on itself, this balloon can also do what's called inducing a charge in something else. So if I put this balloon next to something like a wall, what will happen is that all the negative charges in the balloon don't like the negative charges in the wall. We say opposites attract. And if you have a positive and a negative charge, they will try to move towards each other. Similarly, if you have a negative and a negative charge, they will try to move away from each other. They are repelled. Like charges are repelled, so a negative and a negative will try to move away from each other. A positive and a positive will try to move away from each other, but a negative and a positive will try to move together. So what happens is the negative charges in the balloon kind of try to repel the negative charges in the wall, so they all kind of move away. And what's left is the positive. So what you end up with is a sort of area of positive near the balloon. And of course, negative and positive, they attract. So I'm going to demonstrate that, not with a wall because I haven't got one handy, but with some little bits of tissue. It works exactly the same in little bits of tissue. So what I'm going to do is put my bits of tissue down here. I'm going to rub the balloon. This will induce a negative charge in my balloon. When I hold it near the tissue, it will induce a positive charge in the tissue, which is then attracted. And we can see them there, starting to dance a little bit. Need a bit more charge in it, I think, don't I? And you can do this with a wall. You can actually get balloons to stick to the wall. Works beautifully with hair as well. Oh, hey, that was good. Oh, yay. There we go. So the top end of that tissue next to the balloon is positively charged, and the bottom end is negatively charged, because that's where all the negatives are being repelled to. So that's a little bit about static electricity there. Places we come across it are, as I've said, lightning, and that's happening because of the movement of the clouds up there. One particular place we get it is clothes that have come out of a tumble dryer, because you've got clothes being rubbed against each other. Some of them gain a positive charge, some gain a negative charge, and when you move them apart, you'll get a positive and a negative next to each other, and if you've got sufficient number of volts, the more positives and the more negatives, that's the more volts there are. If you get enough of them, loads and loads of them, then you'll get a spark as they jump across and try and equalise itself out. So you get the electrons will jump back, so you've got like neutral charges on both. And you can sometimes see that as a spark if you unload the tumble dryer at night in the dark, which I'm sure you all do. Sometimes you'll see these little bright blue sparks. Same kind of thing if you get it on from a car, for example. This can cause problems. There are a couple of places where static electricity can actually be very dangerous, and one of those is filling a car with fuel, because you can get a static charge build-up as the fuel flows through the pipes. Now you think, well, that's okay, so you've got, you know, a static charge in your petrol tank. The problem is these sparks. When you're filling up petrol tanks, you've got a lot of petrol vapours, and petrol vapours are actually incredibly flammable. Petrol itself isn't. You can't actually light petrol itself. It's petrol fumes that are the dangerous thing. And if you get a spark with lots of petrol fumes, it can actually cause an explosion. You get the same kind of thing in things like flour mills as well. Again, this kind of powder moving through the mill, as these things do along chutes and stuff, can generate static charges. And you wouldn't have thought it, but flour is actually explosive. When it's in the air, flour dust and things like that, any finely divided powder, milk powder is particularly good one, I'm told, any of those can be explosive, and they can cause serious damage. So a lot of machinery has to have earth straps, which what it basically means is it's a piece of wire that goes down and is literally buried in the earth to let all those charges escape. So if you ever see earthing straps on machinery and things, that's what they're for, there to let the static charges dissipate. So that's a couple of places where static electricity can be very dangerous, but it can also be extremely useful. Most cars and bikes and things like that are painted using static electricity. What you do is you have a static charge, you induce a static charge on your, say, like bike frame, and you make sure that your paint is finely divided droplets with the opposite charge, and of course opposites attract. So if your bike frame is negatively charged and your paint particles are positively charged, all of your paint will go and fly straight to the bike frame and coat it beautifully. Sometimes you hear about things being powder coated. That's done the same kind of way as well. It's using static electricity to make sure that all the paint goes into all the nooks and crannies very beautifully and makes a very good, very fine finish. Rather clever, isn't it? So that's a little bit about static electricity. Have fun with some balloons and cloths and things. See what you can pick up. You can also do it with a lot of plastic containers, things that stuff comes packaged in. Try giving that a good rub and then seeing if you can pick up bits of tissue paper with it. Or pepper works quite well as well. You can pick up like ground pepper. So have a bit of fun with that, and I'll see you next time, Batty fans.
Mwahaha! Mwahaha! Mwahaha!